What if a company could predict the future with more certainty, or know which customers would most likely buy their newest product? These are just some examples of the potential around big data. Hello and welcome to Big Data Basics. This video is intended to help you understand the basic components, terminology, issues, and opportunities around the term big data. Big data is about gaining actionable insights by collecting, processing, and analyzing the data being created by billions of devices and millions of enterprises as we go through our day. All this data offers an unprecedented opportunity for companies to maximize performance and gain a competitive advantage. So let's get started. I'll break the video into three main activities. First, data creation. We'll look at where all this data is coming from, how is it being generated, and why is so much data being created. Second, data storage and processing. It's not enough just to have a lot of data. We also need to collect and compute all of it. And third, data analytics. Once we create, store, and process all our data, how do we make sense of it so we can benefit from it? Our first activity is data creation. In case you didn't notice, we live in a data-driven culture. Today, we have the ability to generate data in amounts never thought possible in the past and to digitally store all our data very cheaply. This is the result of having the right price and performance around key components. Here's what I mean. Our first graph, Moore's Law, shows the cost of computing goes down while performance goes up. The next graph on the right shows the price of memory has dropped so much that memory is basically free, giving us the ability to save everything. These graphs show smart devices are getting cheaper while gaining more performance and features. The cheaper and more powerful these devices get, the more people want them. As more smart devices become available, connecting more people to each other and to the internet, the more data is created. But it's not just billions of smartphones. As the graph on the bottom right shows, it's also billions of smart sensors. So we have billions of smart devices all generating data every minute of every day. Making sense of the river of data being generated by intelligent devices is one of the key components of big data. So let's talk about all this data. In the big data world, people refer to three dimensions of data generation: variety, velocity, and volume, the three V's. Variety refers to the different types of data formats, like audio-video files, emails, or Twitter. We'll discuss variety in more detail shortly. Velocity refers to how fast the data is coming or streaming. For example, Twitter produces 400 million tweets a day. And volume, the amount of data. Today we gather data everywhere, from weather patterns, medical images, and customer behavior to those smart sensors monitoring the world around us, and many, many other sources. All these generate huge amounts of data every minute of every day. With big data, it's important to know that not all data is the same. The variety of data types plays a huge part in the big data picture. We can separate data types into two main groups: structured and unstructured. On top is a typical example of a traditional database, the structured data we are most familiar with. Neat columns with cities, states, and zip codes. Structured data tends to be in a defined format. Below is what a tweet looks like. With unstructured or multi-structured data, the data is more complicated. With unstructured data, you don't know how the information is presented. How do you sort or store these characters with today's database tools? When it comes to big data, the data most people are referring to is unstructured data. And it's unstructured data where both the challenges and the opportunities exist. So let's look at unstructured data. Unstructured data is being generated in the ever-growing social and business networks and streaming out of those billions of inexpensive smart devices. It seems like everything we do is generating data of some sort. And it's just going to continue. One of the major contributors to data creation is going to be the Internet of Things. The Internet of Things basically brings our world to the Internet. It's the proliferation of small devices that report status or interaction with humans or machines at very high rates using sensors or beacons. These smart sensors are already widely in use, and as we saw earlier, we could have 50 billion sensor-type devices connected by 2020. All these data types allow companies to have terabytes and petabytes of data at their disposal today, and even more in the future. Experts predict the total amount of data will double by 2020. But it's one thing to have a lot of data. It's a whole other thing to be able to take advantage of it. So what's standing in the way? What's standing in the way is today's technology. Unfortunately, there are three key limitations with today's technology as it relates to big data. First, there's the format of unstructured data. As we mentioned, it doesn't work well with today's traditional database technology. Second, today when we generate data, the data goes to a centralized server to get processed, then off to a database to get stored. When we want to retrieve the data, it goes from the database back to the server and then sent back to us. The problem is, as the volume of data explodes, the process of moving all this data back and forth will make computing slow and inefficient, and performance suffers. Third, today's systems don't scale efficiently with their expensive servers and expensive and complex database licensing. So as many companies want to save more data, it will get increasingly expensive and complex by having to add more expensive servers and more licenses. So today, companies are faced with formatting, costs, and performance limitations using today's technology. And it's these factors that are preventing the majority of companies from benefiting from the big data opportunity. So let's summarize our first activity, data creation. With billions of smart devices and sensors, the variety, velocity, and volume of data being created is enormous. And most companies are struggling to get a handle on all their data. Unfortunately, the majority of this data is unstructured data and can't be exploited using traditional computing technology, forcing IT departments to throw the bulk of their data away, over 85% in a lot of cases, thereby tossing the majority of information that could be useful to the company. So in response, an increasing number of organizations are turning to a new technology to store and process the unstructured data, and turn the data being wasted today into a valuable resource. Which brings us to activity number 2, data storage and processing. So let's start with an analogy. Think of a river flowing out to the ocean. Assuming we want to use the water for irrigation or for hydroelectric power, we would build a dam. By applying technology, we can store and process the unused resource, water. In the same way as our dam, if we want to harness the potential of our unstructured data, we need to implement a new technology to store and process our unused resource data. A technology that can efficiently store our terabytes and petabytes of unstructured data so we no longer have to throw data away and can process large amounts of data. To understand how we can do this, we need to step back to early 2000s so I can give you some industry background and introduce 3 key players in our big data story. Back in 2000, Google was a search engine company. Google's mission was to organize the world's information. That meant copying and indexing the entire internet continuously. But by the early 2000s, as the number and size of websites grew and Google's service became more popular, Google was forced to digest ever-increasing amounts of data more quickly. So Google had to design and build a new infrastructure to solve this problem. In 2004, Google published a paper outlining their approach to storing and processing hundreds of terabytes and petabytes of data. Shortly after the paper was released, the open source community began working on their version. By 2006, an open source version of Google's technology was in production. It was called Hadoop. At the time, Hadoop was used mainly by web companies like Facebook, Twitter, and LinkedIn. Today, Hadoop is supported by the Apache Software Foundation. It is the open source implementation of the technology Google invented and is free to anyone. You'll sometimes hear the term Apache Hadoop. This is why. Let's talk about Hadoop. I won't go into too much detail, but the key to Hadoop is it runs on inexpensive commodity servers, each server having a local disk and CPU attached. Hadoop has 2 key components. The first is Hadoop's distributed file system. Inside Hadoop, there's a storage component based on Google's file system, which provides scalable and reliable storage by chunking data into blocks and spreading the data out on the local disks on each of those inexpensive servers. But it's not enough just to store vast amounts of data. The data must also be processed. So after the data is spread out and stored among the servers, Hadoop can process the data based on another Google technology called MapReduce. MapReduce divides the data into small parts, and the data can be spread out among thousands of servers and can be executed simultaneously across all the CPUs. This is called parallel computing. So data no longer has to be transferred back and forth across the network and funneled through a central server to be processed. So Hadoop is central to our big data conversation as Hadoop addresses the limitations of today's technology. Hadoop allows businesses and organizations to do things we couldn't do just 5 or 10 years ago. By leveraging technology forged at organizations like Google, Twitter, and Facebook, Hadoop has broken into the enterprise, proving to be the ideal platform for organizations who need a scalable, cost-effective, and flexible data storage platform. With Hadoop, enterprises can now explore the power and profit potential of their data. But Hadoop is not big data. Hadoop solves a major issue as a new data platform, but it's only one part of the big data picture. So now we have our data, and we have a way to store and process our data. Now, all that's left is for us to make sense of all our data. This brings us to our third activity, data analytics. So now we have to shift our big data conversation from how do we store and process data to what can we do with the data? Is there value in it? To make sense of all the data, we need analytic applications and someone who has the ability to find and interpret the data sources. These people are called data scientists. Data scientists are modern-day knowledge prospectors, penning for insights, patterns, and trends that reside in all our data. So when analyzing data, no individual record is particularly valuable. You can't study a small portion of data, as you see here, and expect to get the whole picture. Since Hadoop allows companies to store and process all their data, the more data organizations have to study, the better picture they can get from their data, and therefore, the better their results. So let's look at some ways companies can leverage their data using Hadoop and data analytics. Chevron analyzes vast amounts of seismic data to find potential oil reserves. By improving their odds to find oil means they can drill fewer wells to find the same amount of oil, resulting in huge cost savings and reducing the environmental impact. By tracking weather, insurance companies can inform customers by text of a possible hailstorm. Customers can then move their cars undercover before the storm hits, thereby reducing the number of claims for the insurance company. Today, as people text, surf the web, or use Facebook, these activities create events that can form a profile of behavior. All this leads us to a new age of data-driven organizations, those that use data to yield a better return on investment. For example, companies can increase cross-sell or upsell opportunities by targeting specific customers and not swamping entire groups with unrelated information. Or companies can proactively make offers real-time while customers are in the store or as they enter. Or companies can design better products or services for customers based on analyzing social media to learn what customers say they want. So let's look at another scenario for big data. Today, sensors are all over airplanes. By monitoring data from millions of sensors and analyzing the data, an airline can determine if an abnormality occurs real time. If an event happens in one engine in their fleet of planes, the airline will be made aware of this issue and can notify the maintenance crew at the airport where the plane is flying. The maintenance crew can replace the troubled part immediately before the engine breaks down, avoiding having to take the plane out of service, thereby improving customer satisfaction by reducing the number of flight delays. Today, flight delays cost airlines over $8 billion a year. Here's the real value in big data. If analyzed correctly, big data is capable of unlocking useful insights and trends from a wealth of data, which can benefit many industries. Just a 1% savings across major industries can potentially account for billions of dollars in savings and economic activity over the next decade. The opportunities from this marriage of data and analytics are multiple and significant. So in addition to the industries listed here, other industries using Hadoop include financial services, governments, manufacturing, and telecom. So let's sum up what we've learned. Today, the amount of data we are generating is exploding thanks to a growing number of data types. Unfortunately, there are limitations with today's technology when it comes to the bulk of this data, or unstructured data. These limitations prevent companies from being able to store and process all their data, causing the majority of data to be tossed away. Fortunately, now there's a new technology or data platform called Hadoop, based on Google technology. Hadoop allows organizations to collect, store, and process massive quantities of data from different data types on commodity hardware. With Hadoop, no amount of data is too large. This allows our previously unused data to now be usable. Most companies are data rich but information poor. With Hadoop and data analytics, enterprises can gain insights out of their mass amounts of data to reduce operating costs and unlock productivity gains. So a company wanting to do a big data initiative on their own might find it a little overwhelming. Fortunately, there's an ecosystem of solution vendors to choose from. Pure-play Hadoop vendors like Cloudera, Hortonworks, and MapR Technologies are developing, supporting, and marketing unique versions of Hadoop called distributions, with add-on innovations and services for IT groups to adopt. In addition, all of the large enterprise software vendors have a Hadoop strategy because it's an essential data management technology, and they tend to partner with one or more of the pure-play Hadoop vendors. Big names like Intel, Yahoo, and Microsoft devote significant engineering resources to improve Hadoop's performance, compliance, and usability. While other vendors offer Hadoop-specific tools, features, and services to make their Hadoop solution attractive to the enterprise. Today, cutting-edge enterprises are investing in resources to exploit data to gain actionable and relevant insights to increase profitability. The benefits that big data can bring, better decision-making, the identification of new trends and opportunities, and improved responsiveness to customer needs are all there for the taking. In a world where information separates winners from losers, data-driven organizations are leveraging today's massive data explosion to create a competitive advantage. So that's it. I hope this video helped you to better understand the basics of big data. Thanks for watching.